Hooray, we're live. So this week we will implement operator precedence. The nice thing about that is that we don't have to change anything in our interpreter or in our abstract syntax tree. The only thing we have to change is the parser and the way it builds trees of arithmetic expressions. So first of all, what does operator precedence mean? It means that, we talked about that before, but it means that essentially some operators bind with more precedence or more priority, like for example, multiplication will always bind over addition. So a plus b times c will always be parenthesized like this. So that means a plus open paren b times c, even if you leave out the parentheses. All our operators associate left to right, which means that if there's an expression with more than two elements but the operator is always the same, it'll be or they all have the same priority, then left, parenthesizing from the left, is prioritized, which means that a less than b less than c, which is probably not a very useful expression, will be parenthesized as a less than b in parentheses less than c. And the way our grammar changed is that now we have two different levels, if you want to call it that, of expressions. The one that's the lower level is the primary, and then the one that sits above that is the expr, which is where the operator precedence happens. And essentially a primary is something where precedence doesn't matter. So the only time the precedence shows up is in the expr. And the expr is simply primary and then an operator and another primary and then another operator and another primary and so on. You know, any number of operators, but at least one primary. So let's go to our parser and look at our stuff. So first of all, we had one rule. First of all, we should probably rename this to parse primary. Then also note that the expressions, the recursive expressions within the primary are still the top level expressions, right? So within an if, you can again use binary operators, which of course makes sense. So these two call each other recursively, which means that the only exception is the unary operator. We don't need any precedence to well, so here's the thing. It is totally possible to have a grammar in general, you know, talking about the hypothetical programming language, where unary operators have precedence that you need to handle too. For example, you could have a unary operator that is postfix, and you could have postfix as well as prefix unary operators. So let's say we have a plus plus and a minus minus operator, and one of them is prefix and the other is postfix. So if I say minus minus x plus plus, do I mean minus minus x plus plus, or do I mean minus minus x plus plus? And the other thing is that this unary operator could be super low precedence. So it could be that minus minus x plus y actually means not minus minus x plus y, but it could mean minus minus x plus y. But we don't have that. All our unary operators are high precedence, and they are all prefix, which makes this very easy because we don't have to care. If we get a unary operator, we just parse another primary, and it's very easy to resolve precedence because precedence basically doesn't exist. What it means, however, for our primary parsers is that we need to take the binary operator rule out. So the rule that we had before, this one goes out, and this basically splits up into two rules. The one rule is that you can parenthesize expressions. And the second rule is that now expressions are a separate thing. So let's do that. First of all, we have the paren thing. And this is different now because it's just paren expr paren close, which really means that all I have to do is parse an expression in the context and then expect token close paren. So that's a very simple rule. I'm going to take this out because we don't need it. But now I need to implement exprt parse expr. And I probably don't need to export this. I'm just going to paste this here. But I need to forward declare it. Otherwise, parse expr can't call it. So the parsing alone is pretty simple. Another thing. I forgot the unop. This is a primary now. So this has to be parse primary. And all the other stuff remains the same. So what we can do is we can just parse an expression, right? And then how did we do look ahead? Look ahead dot type. And then we can say, oh yeah, we have this thing. And then we can say while we have a binary operator, look ahead dot type and look ahead. Oh, it's really ugly. Static pool is what is it, token type T? Oh, this is not much prettier. Yeah. I was going to say. Okay. On your place. Oh, yeah. I can actually see them. So while the look ahead is look ahead dot type. No, you're fine. No, I'm not supposed to do that. So while we have a binary operator, what do? We consume the token. Consume the binary operator, and we parse another expression. And of course, we don't know yet what we're going to return. So this is the easy part, right? Just accepting the expression correctly, basically. Except that this should actually be primary. And Bate did not pay attention, and neither did Felix.
And you're just consuming the thing. You're not.
Well, yeah. So now I need to figure out what do I actually do.
I don't know what you do.
What do I actually need to do to produce the proper expression and not just accepting it. So we talked last time about at least 2 ways you can do this, and one of them I linked to this shunting yard algorithm, which feel free to implement, but I'm too lazy. We're gonna do it the simple way, which is something that I also told you about, namely, we're just gonna read all of it in. So we're gonna read something like 1 + 2 × 3, just as a list or dynamic array. And then we're gonna go through the precedence of the operators. We're gonna start with the highest operator precedence, and we're gonna go from left to right, look at the operators, and if any one of them is of that precedence, we're gonna basically parenthesize those 2, and then from then on treat them as 1. Which means that we have to make 4 passes over the whole thing. Which means that first of all, we will have to generate this data structure. And I think what we should do is have 2 arrays, one of which is the expressions, and the second array, the operators in between. So we would have an array that's 1, 2, 3, and then the other array would be plus and times. Does that make sense?
But then you have to like, you have to like know which one of those expressions are associated with the operator, and you have to do some math with that.
Yes, you have to do some very simple math, which is basically +1. So this is index 0, right? So this is 0, this is 1, this is 2. Maybe I should have called this A plus B times C. So this is A, this is B, this is C. So the operator at index 0 applies to expressions at index 0 and index 1. So basically, the operator at index I applies to I and I plus 1.
Once you have to put that into append, or actually then you have to insert.
So yeah, so what happens now if, say, we do our first pass, right? And we find the times here. So what we do is, maybe I should have added plus here and D here. So we have A plus B times C plus D, right? So what happens is we look at this operator, we decide we have to parenthesize this, which means that these 2 get grouped together with that operator, meaning that we delete this from here, sorry. And these 2 expressions become one expression, which is B plus C, right? I'm sorry, B times C. So this becomes one expression now. At index 1 and at index 3, we have that. Does that, oh, I'm sorry, index 2. that make sense? Felix? Are you still with us? Do we have the thing? Oh yeah, Felix is still there. He's just not talking.
Yeah, he says I can hear you.
Oh,
Everything understood so far.
all right. Okay. Yeah, let's get to it. So we're gonna have two dynamic arrays. Which we're gonna call the expr array, and the other one, and now this is a little bit stupid. Do I want to put? Yeah, I'm lazy. So the thing is that the dynamic array stores pointers, but the operators are not pointers, right? They're basically integers. They're an enum type, but whatever. But we're just gonna cast them to pointers, and because I'm too lazy. So we're gonna make an op array, and I should keep that.
Yeah. Primary array.
Oh, you want to call this primary array?
Mm-hmm.
So we're gonna init the primary array with the pool from the context, and we're gonna init the operator array with the pool from the context. So now, this is easy. We just throw this into the primary array. Find our append primary array. So basically what we're doing is we're parsing first, building up these two arrays, and then we're reducing the arrays with the proper precedence. So here we have to define our append into the op array the type of the operator. So basically this. And we have to cast it to a pointer. And this again gets appended to the primary array. That was easy.
What is init? Oh, okay. Yeah, cool. That's cool. Yeah.
So now we have these two arrays. Now we need to somehow tell. We need to have a way to figure out the precedence of an operator. So what we're going to do is we're going to
reorder the operators.
Yeah, I'm not sure we can do that. No. Also, some of them, like for this precedence, we have two operators. So you can't just go, oh, if this is less than the other, then it has a different precedence. So that doesn't work. So we're just going to say we're going to have three different levels of precedence. And for simplicity's sake, we're going to call this the level 0 because we then can count upwards instead of downwards. So
From the logic is like reverse. If the thing has less precedence than the other, then group, as opposed to higher precedence.
no, we never compare the precedence.
Oh, I see.
All we're doing is we're saying,
Yeah.
is the precedence of this operator 0? So we're going to make a function static int op operator precedence. It takes a token type. And all it does is switches over T. And so we have case token, is it multiply? No. Times? Yes. Return 0. Case token add. No? Oh, it is add. Okay. Return 1. Case token less. Case token equals. Return 2. And then we have token, what do we call it? Logic and logic or return 3. And this must not happen. Insert false. False? False?
It's just the same lowercase.
Using too many different programming languages. Yeah, so now what we do is we count. Yeah, I can inline declare it. This is my precedence, and I counted from 0 to 4. Magic number. Magic numbers are not good, but I'm lazy. So now what do I do? I need an inner loop which goes over the operator array. What is it, dynar length? Of the operator array. And now, if I only want to do something if that operator is of the precedence that I'm currently looking at. So if the operator precedence of token type T of dynar nth operator array I. If that's a different precedence, then I'm going to continue. Otherwise, here I'm doing business. So now what do I need to do? I am at position I. So let's go back to where we were before 3. I'm at position I, so let's say I'm at 1. I need to make a new expression that's a binary operator expression that uses the operator at position I, and the left operand is the expression at position I, and the right operand is expression at position I plus 1. So let's make that expression. Here we're making expressions. So we're allocating a binary expression. The left one is dynar nth, primary array of I. The right is I plus 1. The operator is, let's token type T op. This is my operator. This is the expression. That's good. Allocated the expression, but now what do? Now I need to remove the ith entry in the operator array. So let's do that. I'm removing this one. I need to remove the ith entry in the expression array and replace the resulting ith entry with my new expression. So this is where we get b plus c. How are we going to do this? I guess we're going to have to implement a new function. We're going to call it dynar remove in the op array. We need to remove I. In the expr array, we need to remove I primary array, sorry. Yeah, and then we need to, we also don't have a set, so we're going to say dynar set in the primary array. Well, now it's not a primary anymore, so maybe I should have called it expression array.
Yeah.
Oh, damn. Didn't think of that. Prime array with x. No. Prime array with x per. Okay. Set at I the new expression, which I should also declare. Now, at the end of this whole procedure, can I assert something?
So that the op array is empty and the expr array has size 1.
So the operator array must be empty. If that is not the case, also, also, there's another thing. So let's put this down first. The expr array must have 1 entry. That is correct. If that's not the case, then we have either not reduced an operator, or there's like a non-operator thing in there. There's like an operator of an unknown precedence in there, right? So neither of that should happen. There is a mistake in this loop. What is the mistake? And I'm not talking about this code at all. This is totally fine. I mean, maybe there's a mistake in there too, but I don't know that. There is a mistake in which how we're counting up. So what happens? Let's say we have the expression a plus b times c times d, right? So we would have times.
Oh yeah, yeah.
What is it?
So
Tell us.
so basically, if you delete or remove that operator and then go through it again, you'll like go out of bounds.
I might go out of bounds. No, I will not go out of bounds because I have the bounds check here. But what will happen is that I will jump over 1.
Oh, yeah.
So what happens is, let's say I reduce this first times, right? So I basically I do this by removing this, making this into b times c. So I was at index 1. I was 1 when I did this. And now in the next loop iteration, I becomes 2 and I'm already done, but I shouldn't be done. I have to look at 1 again, because 1 is now the second times, right? So in other words, I'm just gonna transform this into a while. So while I'm within the array, if the operator precedence is not the one I'm looking for, I'm skipping that operator. Otherwise, I'm doing all of that stuff, and then I'm going to look again at the operator at position I. Or maybe if I'm at the end of the array, I'm done with that precedence. Let's look at, does this also work when I'm already done with all the operators? Basically, when I'm already done with all the operators, the array should look like this. There would be 1 expression in there, and there would be no operators in there. The expression would be this, of course. At index 0, there would be no operators. What happens in that case? I start with I equals 0, and I execute this while I is less than the length, but the length is 0, and 0 is not less than 0. So I wouldn't do anything. Basically, we're running empty. So that's fine. I could do an early break, but there's just no point. It's just 2 lines of code that, whatever. If we had a million different operator precedences, that would be a different thing. But in that case, we're probably screwed for other reasons. Okay, so what do we return? What's the result? Yep. And that's it. Now, of course, we have to implement this remove thing. So, oh yes, and set. Void dir remove. We're going to take an array. Oh my God, what is wrong with me? And an index where that will be removed. And then we also have set. And that I'm just going to void dir set star p, whatever. I call that p. I need to be sure that it's in the array. And then I'm going to say data of I equals p. So that's easy. Now let's implement remove. nrc and remove. How do we do this? Well, maybe first we should have said something. Yes, that I is less than the length of the array. And then we can just use mem_move. So the difference between mem_copy and mem_move is that you can do a mem_move if the 2 regions of memory overlap. So what I'm doing, basically, I'm telling it, let's say we have 0, 1, 2, 3, 4, 5, 6, 7, and I want to remove 3. What I'm saying is move this part to here, right? Basically shift that memory left, thereby deleting this. Of course, it's copied, so really what happens is that the 7 stays here, right? So we now have 2 7s, but that doesn't matter because we're decreasing the length, so it's all good. Like, we don't care what comes after, the rest of our array. But I cannot use mem_copy because these 2 regions I cannot use mem_copy because these 2 regions overlap, and mem_copy might do anything. So we are moving to, where are we moving to? Theta of
minus 1. Oh, wait. Remove of I.
Yes, we're moving to I from
Plus 1.
I plus 1, correct. And we're moving how many?
Minus I.
Length minus I. Plus 1?
No, I mean minus length minus. Wait. Minus 1. Length minus I minus 1. Wait. Length.
So let's say we remove the 0th element.
Yeah.
Then for sure we're going to have to remove 1 less than the length.
Yeah.
Right? So the length minus I minus 1. And then we decrease the length. We could also decrease the length before, and then we wouldn't have to do the minus 1, but whatever. Yeah, I think that's it. Anything I'm missing?
You don't care about potentially accessing outside of the thing.
So what happens?
If you try to remove the very last one.
Yes. What happens if I remove the last one? So let's say my array has length 5, and I'm removing the one at index 4. Then this becomes 0. And that's fine.
And then you're just putting random garbage into.
What do you mean? No, nothing happened. Mem_move doesn't do anything if you give it length 0.
Oh, okay.
It just means don't move it. Like move 0 bytes. Okay, I'm done. There is a very weird thing in C also in the standard whereby you are allowed to take the address of any array element, including the address of the element right after the end of the array, but not any further.
Yeah.
That will result in undefined behavior. That is it. Is that really it? Like that was all? That was pretty easy. But I guess it is. We should, I think we still have the interpreter on, which is fine. Let's see if it compiles. Of course it won't. Token end? No, I don't need that. How did I call that? H token. No, there's end. Not negate. Oh, it is plus. Okay. What else? Oh, yes, of course. That and that. Okay. That was pretty mild. So now, of course, we need some test cases. So we should be able to implement the factorial now, but that's kind of boring. Let's do it anyway. Dropbox work thing. Oh, sorry. This is actually interpreter 10. Let's call this fact.sl. And yeah, it doesn't take arguments. Does that look correct?
Mm-hmm.
Now, of course, this is not, we don't know whether the precedence actually works. So can we write one expression that has like all the operators? So we can do 1 plus 2 times 3. That's easy. So that would be, if it's incorrect, it's 9, and if it's correct, it's 7.
1 times 2 plus 3.
So what other operators do we have? Oh, then we have less. So we can say less. That must be less than. Okay, we can say equals.
Equals 7 times.
No, wait, 1 second. I want to have something that's true. Oh, yes, 7. Okay.
Times or and 1.
And 1. No. Well, no. And 1. Yes, because if it did this, then 7 and 1 would be 1. Right? So the result of this should be 1. But it's probably not 1 if it does anything. So for example, if this here is incorrectly parenthesized, let's say it's parenthesized here. Oh, then this could still, no, this could not be 1. No matter what happens on the left side, this could not be 1. Right? The left side in any parenthesization cannot be 1. Right? So this would be incorrect. Then if this, for example, let's say it does something like this is false, then we would, oh, this is interesting. So if it did this parenthesization, 1 plus, right, so this could still be 1. Because
yeah, that'd be 0.
I don't know why we're doing this. Could we still make it? I mean, I could do. I could make this 5, and then make this 11.
Yeah. And then that would have to be 1.
And then this cannot be. Then it would be 5 if if it does anything like this, right? Of course, we still have the other 2 operators, but I'll leave that. I don't know. I'll leave that to you guys. I mean, let's see what happens. Let's call it all levels. What? Okay, how is this 0? Did we make a mistake? 2 times 3. Okay, let's do it the old-fashioned way. Equals 11 and 1. Huh. See, we made a mistake.
We can find out.
Yes, so what we can do is we can use the parser to just give us the syntax tree. So this is the syntax. What? It's bullshit. Look at that. Whoa. What the hell did we do? Potato, this is all your fault.
Wait, where's the 1?
Yeah, it's gone. It's gone. It's so either we implemented the remove incorrectly, or we implemented or we made some other mistake, obviously. So let's first look at the.
It's like an edge case, I think. But wait,
No,
no, because
this looks like
like look at the very inner parse tree. That looks like that looks right.
No, because there's still.
We're
plus.
just missing the 1.
How are we missing the 1? We have the 2 times 3,
No,
like
I'm
3
talking about-
times.
Yeah, but yeah, we're getting stuck somewhere. But oh shit, this looks right from the beginning, and it's
Yes.
like the 1 is missing from. It got replaced with the. That's what it is. The 1 got replaced with the.
I'm an idiot. I mean, I'm surprised this does anything. I'm surprised this doesn't crash like crazy. Because I'm just shifting sub-pointer sized bits around. Whoa. Okay, let's try it again. All right, this looks much better.
Oh, yeah, even with that, it's not.
All right, wow. It's a beginner mistake. Yeah. All levels dot out 1. And I'm assuming that will work now. And let's see. Oh. Hooray. All right, I'm gonna call it. I'm gonna say this is good. Yeah. Try it out. Try to find another bug. Maybe there is one. So what's up next? So for next time, we have 2 pretty simple ones. I suggest we just combine both of them into one. So the first one is we're basically just introducing this level of grammar where you can declare a main function that takes arguments. We're doing this first, and then later we're introducing having multiple functions that can call each other. But for now, we just have a main function. So one function that's super easy to parse, super straightforward. You have let, and then the name, which must be main, and then you have the parameters equals, and then an expression, and then end. and everything else is the same. And the parameters are just a bunch of identifiers. And the second part is to extend whatever your program is so that it takes as command line arguments the arguments to main, and then that it actually gives those arguments to main, meaning that you will have to build an environment, you know, bindings for those variables. Yeah, you'll also have to build like a little bit that prints the syntax tree, I guess, for this. But again, that should be easy. Maybe I should. Did I ever specify what it should look like for stuff there? No. Okay, let's invent something. Example, let main a b equals a plus b. And then the output, and then as output I want. What do I want? Function, let's call it function. Main, and then just the arguments. No, let's do this with an additional level of indentation. First the function name, then whatever, an additional level for the arguments, and then just at the standard level plus a b. Does that look good?
I think when I did it, I didn't actually put the function in there.
Yeah, I mean, I just invented that.
Yeah, because it's
right now.
It's already kind of implicit because it's a name. And I don't know.
Do you want it without the function?
I don't mind either way.
Okay, so let's do it this way. Yeah, that's it. Any more questions? Did you feel like saying anything?
Not anymore.
All right.
Wait, what?
If not, then oh, thanks. My pleasure. See you soon. Bye.